Quite a lot. Okay, so I'll say at this point, most of this stuff really applies to good practice in general. I'll specifically refer to OO, but if you think of a class as a cluster and a selection of sub-PIs, the modularity concepts kind of go along with a lot of it anyway. But anyway, so I found this gap though when I actually started developing software professionally of, that's great, I know how to build them, but when do I build them? Or when do I decide this class needs to be 2 classes, or these 2 classes should be 1 class? And so hopefully this helps to bring my sort of 2-year learning curve a little bit shorter for you. So the first lesson is you can't be too modular. So this is a pretty common message. If you've ever seen the smallest presentations, modularity is a big thing. And you'll find through a lot of this that there's nothing revolutionary here. But specifically I said you can't be too modular. And this refers to concerns I had when I started using object-oriented programming about the overheads. I'm creating loads of sub-PIs in my project. If I create too many classes, it becomes slow. And so I would be using it, generally that means I would end up creating big classes. If I was going to go through that process, I wanted it to count. But the reality is that got me into trouble on a few occasions. So I've got an example now. There's some code. I don't know how you can see it at the back. The actual code isn't too important. Hopefully the vague shapes will be enough if it's a bit distant. This is an example from a project where I had an alarm engine. So basically I'm doing some monitoring of the shape and temperature. And what I have here is I've got a class on the top, which is my alarm engine. It tracks whether we are currently in a high-level alarm and compares the temperature to the alarm level. And if we have a rising edge, which is what this little compound arithmetic block is doing, then we run some code, which I've hidden because it's not too relevant here, that will actually report that alarm to the user. So that was pretty simple, but as happens in Agile and in all environments, the customers want to change things. And so they said, this is great, now we want you to be able to clear the alarm. So we want to be able to press a button and say, if we're in an alarm state, we don't care, don't report it to us anymore, we've figured out what's wrong and it'll recover itself. So that raises some interesting questions. The first thing is, my logic here is going to get more complicated. And I now need to start tracking in my alarm manager whether we've cleared this alarm. So this starts to feel a bit object-oriented. We've got some data and we've got some methods for that data. The other big rule I broke here was don't repeat yourself. I actually had this logic for 4 different alarms. And I kind of hadn't registered this until I had to come back and do this change. So again, it's probably a little bit hard to see. This bottom alarm is a bit more complicated, but I still have my Boolean in and out and my basic little compound arithmetic. So I made a class, and it was tiny. And it's something I probably wouldn't have done a couple of years ago because I'd be worried about the overhead. But the reality is the overhead of a sub-PI call or even a class is very small for the vast majority of applications. So this one just has my 2 booleans. I had 3 different methods. One for the raise alarm, which replaced my compound arithmetic. Another thing with being modular is your readability is so much better. And actually, I rank readability at pretty much the top, other than working code, of my priorities when I'm writing code. Because now I don't have to care and figure out that compound arithmetic is a rising edge alarm. I just have raise alarm, and I don't worry about what's happening in there until I need to. In this case, it also let me do a nice little thing, which is this alarm active. So obviously I had to have logic to know whether it's cleared or not. So I just hide that in this case a small PI. I don't even take up the whole thing. It's just a nice little helper that again reads really well in the diagram. You don't have to guess what that function does. Lesson number 2 is design interfaces looking down. Interface is a bit of a funny term in LabVIEW. I tried a few terms and I wasn't quite sure what to settle on, but what I mean by an interface is really the VI calls that you provide as an API to the level above. So, or in the case of object-oriented programming, also the type of class you create. So this example here is something that I've done. I've seen many other beginners to object-oriented programming do. We decided we want to use object-oriented programming on this project. And in this case, this project is a test system, and one of the things we have to do is use a relay to switch on and off a main switch for the item of the test. So what we do is we go, okay, well, I know I'm going to use an NI9472. That sounds like a noun in the examples, that sounds like something I can create a class for. We go, well, what does a 9472 have to do? Well, we need to configure it. We need to tell it which channel we want to write and what the value of that channel should be. So our test system, looking down, sees a 9472 module, and it has to tell it which channel the relay is connected to and where we want to toggle it each time. And this does work, but there's a better way. What I've started to do now is consider my interfaces from the top rather than the bottom. I don't know if any of you caught Dimitri's talk yesterday. So he's kind of a bit of a pro with the object-oriented agile concepts. And he described it really well as it's about getting back to just what's essential for the level above. So our test level doesn't care that we're using 9472. That's a detail that doesn't matter when you're reading your test code. What matters is we have a main switch, and we switch that on, and we switch that off. And quite frankly, when you're looking at the test, you don't care about any more detail than that. That's the essential element of what it needs to do. Now underneath that, then we need to talk to the hardware. Another interesting thing I find with this is you tend to get more reusable code, because you could go, well, what's essential for the main switch to use a DAC card to switch them? And it's like, well, actually, it can work with any DAC MX code. We need to know the channel at this point. So it's not that we've got rid of that, it's just that we've put it at a level where we care about that. So that kind of makes sense. Probably one of the more abstract ideas. But again, for me, I've started doing this, and the readability of my code is so much better. Because at each level, you have things defined in the right terms. And okay, you have to dive into sub-VIs a bit more, but if it's modular, then you just have to go and find the right sub-VI. One thing I really like with this technique is when a customer phones me up and says we want to add a DAC card, and I haven't looked at his code in a year, I don't have to look at most of the code. I go find this, the main switch or the DAC class, and I know that's the only bit I need to change. It really does help with things like that. This was also, I'm sort of breaking my promise. It's got a little bit of a computer sciencey feel to it, but bear with me. Lesson 3 is don't mix levels of abstraction. And again, let me define what I mean by a level of abstraction. We find that software tends to have these kind of natural layers to it. It's kind of what we saw in the last one with having a test and a main switch and then the DAC MX API. I've got another example here for that DAC process with an alarm. You can vaguely, and I don't say you should do this rigidly, I tried doing this rigidly and it's a pain, but for the concept, you can kind of say there's an application layer, and this is normally kind of where your architecture is. You say you have a DAC process, you have an alarm process, you have a model layer in the middle, or you could call it a business layer or a business logic layer. This tends to be kind of still somewhat abstract, but now it's doing a bit more work, so like an alarm library or a particular DAC system. And then underneath you have your APIs, how you're interacting in and out of the application. Each 3 of these layers in this example are kind of requiring you to think in a different way. If you're down at the API layer, you're in a lot of detail. You have to understand that API has probably been provided to you. You haven't designed it, so you have to understand how to translate your software to use that API. In the middle, you're getting quite specific. At the top level, like I say, you're maybe thinking more at an architectural level. How do I communicate data back and forth? And so, if we try and just keep to one of these levels at a time, you just have to make less mental leaps. You have to remember less things. This is where I always try and come back actually. Well, actually, LabVIEW is supposed to be flow diagrams. If someone asks you, how do you acquire data? You don't give them every level of detail straight away. You have a more basic diagram at the top. And then if they say, okay, that's interesting, but how do you save the data? Then you dive into how you're using the TDMS library or something like that. So I think actually that's an analogy we need to remember more often than we do. So I have an example which again has quite a bit of code. Again, the exact details aren't too important, but I'll try and summarize. So this is from like a library that I had that's using variant attributes for a variable table. So we had a dynamic number of systems adding or subtracting from the software. So what this is actually doing is I've got two variant tables, and this VI is called delete system. So we've got a couple of VIs to decide how we find those elements in the tables, and we have all these variant primitives to define how we do that. So here, I'm having to remember how I'm using these tables and how I'm transporting those around, and then getting down into the nitty-gritty of the variant tables. A really good sign that you're breaking this lesson, if you like, is I've also put a comment for each block, because that's kind of a sign that I'm looking at this and I can't tell what it is straight away. So I need a comment to help me remind me. So this comes back to a very basic principle: make a sub-VI, hide the details away. Now I know the way I delete my system is, maybe not the best time, I delete it from this table, and then delete the data tags from the data table. And if I care about how I delete the data tags, because that's where the problem is, then I go into that sub-VI and have a look. If I don't care, then I can stay at this level and kind of mentally work at a higher level of the software, if that makes sense. Lesson number 4. If you have ever seen me talk anywhere before or read my blog, you'll know I'm kind of a bit big on unit testing at the minute. It's something that I've done heavily for a year now, and it's hugely powerful, especially when you use it working with object-oriented programming. The main reason I love it is it forces you to be more modular. It forces you to break down your application into something small enough that it's useful to test it, and typically you end up with better code because of it. I'm not going to go into vast detail on this here and now because I can talk for a very long time on the topic. But it's certainly something to investigate. Personally, I use the VI tester tool from JKI, but there's a couple of others around. And what it really means is I have everything is okay button. So I write my test when I write my class, and then I can just push a button, and my projects typically maybe have 100, 200 tests. And within 10 seconds, it goes, yep, nothing seems to be broken. It's not foolproof, but it's a very nice feeling. More recently for me, and these two really go hand in hand, is thinking more about refactoring as well. So I mentioned about agile and agility, and how part of the problem is that a lot of agile projects have is they kind of call it code rot, technical debt, typical terms. And what that really means is, as they keep changing the software and changing the software, adding features, tweaking features, they don't step back and update the design. And so over time, the design becomes poor. My favorite term for it was coined by a guy called Owen Bob. He calls it flaccid scrum, because their kind of work they get through starts to drop off over time, because everything is just harder to work with. So more recently I've tried to dedicate more time to step back and refactor. And specifically, I originally tried to do it just as part of my normal process. Oh yeah, when I see some bad code, I'll refactor it. But you don't. We're engineers, we like to solve problems, when you get a feature in, you sort of are looking forward to getting on to the next one, and I tended to skip over that a lot. So now what I try and do, I found a tip in a book that I'll reference in a minute, is he says you have to have a separate feature development hat and a refactoring hat. You have to actively decide to put the refactoring hat on and just spend some time improving the design. And I know it can be hard to justify, especially if you've got someone looking down your neck as to why you're not adding new stuff. But all I can really say is try it. Form it as an experiment, explain it as, I won't do it if it doesn't pan out in the long run. But I think you'll find that the investment does pay off. So now I try and do this regularly. I especially do this when I'm about to add a feature to a bit of code and I look at it and I don't know where to start. So that normally means it doesn't fit very well with that code. So I take, it can sometimes be 10, 15 minutes, just step back, say, okay, is this design still valid? Can I modularize this more perhaps? Can I improve on this in any way? The reason I've put them both on the same slide is because they're very relatable. And what I mean by this is, if I've got my unit tests, I have an okay, everything's okay button. Refactoring can be a very, very scary process if you don't have an easy way to validate the code is still doing the same thing as you think it is. So I can appreciate if you're not doing the testing, it can be very difficult to build in a lot of refactoring. And so do testing. Oh, yes?
How do you know that it's time to look at your code and refactor? And if you've been the one to develop the code, how can you see what it is that you, how can you see what you need to refactor?
Yeah, that's a fair question. Yeah. And the honest answer is I don't have a perfect answer to the first bit of when to refactor, when do you decide to refactor. Like I say, I find, firstly, a good time is when you're about to add something to that code, because it feels more worthwhile, because you know you're about to get the benefit from it fairly immediately. And I think when it starts to feel difficult to work with the code, that's your alarm bell really. When you feel like the code is getting in the way of what you're trying to actually do, which I know is very vague, but it's a good indication. I think if you've written the code, that's a fair point. At the minute, personally, I've found that actually normally it's either your thought process has changed because you now know what you need to do with it. So it might be the refactoring. It doesn't mean you did it wrong in the first place. It just means that we have new information, we have a new feature to add, so with that information you can do it better. Obviously code reviews can help though. If something is sticky, if something is hard to work with, then if you have someone who can look over your shoulder, that's probably a useful process as well. Lesson 5, which is sort of a lesson. One of the things that I personally really enjoyed about understanding more about object-oriented programming is it gives me a much more common language with other developers. LabVIEW is different, and there are concepts in other languages that don't translate well to LabVIEW and vice versa. But there is a lot of commonality as well. So now I've started to use object-oriented programming, I can now have better discussions or learn more from Java programmers or C++ or C# developers and take some of those concepts to improve my code. Up here I've got an example of a few books as well. Again, you won't find many LabVIEW books on the market. There are some, but there's not a lot and they're not very frequently coming out. All of a sudden we have other books we can consider. I've highlighted, two of my favorites and one that was relevant here in terms of books. Code Complete is a wonderful book. If you are a professional developer, I would highly recommend trying to get your hands on one. It covers everything from error handling to these object-oriented concepts. It's very broad, and I didn't read it cover to cover. I just kind of dipped in as topics became interesting to me.
So funny enough, I'm reading the last one right now, and I find if you try to do what you just said, if you try to read it really cover to cover, you really have to start understanding Java or 2++, sometimes very deep levels. So do you just keep that, or you look on the surface to just understand what they're trying to accomplish?
Yeah, so probably the latter. I certainly, so again, this was brought up yesterday. How many people have ever finished this book? I don't know. The Agile Software Development. I have a copy. I read the start of it when I'm not quite there yet, and now I want to go back to it because I understand some of the basic concepts better. Pardon?
You knows it by heart.
Yeah, exactly. So I'll be at Dimitri's level when I get to the end of it, hopefully. Yeah, it's heavy going. I think in terms of the examples, sometimes it's just not relevant. So the refactoring book is quite like that. The first couple of chapters are very kind of philosophical, if you like, and so that's very relevant still. And then it goes into loads of specific refactorings for Java, that version is written for. And so you have to kind of, well, the first thing is if you know vaguely C syntax, then you can normally read the code and get the gist of what's going on, even if you don't know the detail. And so the hard bit is translating, is this still relevant in LabVIEW? Which I think most stuff is to a point. And like you say, you have to understand the reason why they're doing it, it's most important. So one of the reasons I've kind of stepped back from the Agile software development, and I find we have that learning curve, is so like object-oriented design patterns. The NI course goes into it really quickly, as does this. But actually, it didn't make sense to me at the time, I struggled with it. So, but now I've taken a step back and I understand the solid principles, which is also in that book at the start of it. Now the design patterns make sense because I can get the philosophy behind them, the kind of why as much as exactly what they're doing. It's a bit of a long answer, but that sort of makes sense. And happily, I've covered most of my books now as well. So yeah, these are great books, but the point is as well is we can, once you're talking in this kind of common language with people in other languages, there's also obviously lots of resources on net, other books as well, which we can start to bring in and improve our LabVIEW programming and come teach people about it as well. So that, actually a little bit under time surprisingly, is what I have. So my final thing is learn from me. I do tend to blog on my developers' website, devstore.tech.com. I'd love to hear your comments on this talk and other things. I love discussing these things. But yeah, let's say software engineering and LabVIEW FPGA are kind of my thing at the minute. I'm very interested in talking about them. Are there any other questions or anything you would like me to clarify? Yep.
I understand the benefit of programming, but when I use a LabVIEW to program applications, first the action is still not good. We have a general guideline for what type of applications.
So if I'm honest, I would say all of them. I think it's very hard in LabVIEW because it's not widely used. So there's not a lot of examples, but a lot of people use kind of like functional global variable paradigms or action engines, or you see people creating libraries with clusters, and really they're OOP as well, just a different way of doing it. So I think it can be applied really to any application, but you won't find a lot of examples of it, and that can be a bad thing. Be my gut in terms of how you start with it. I think, to be honest, you sort of just have to pick one and go with it. To be perfectly frank with you, I use it for all my projects. It's just a way that I put that together. So it applies to it. Yes.
So in a sense, it's dead. Until we call it method, it does nothing.
Yep.
As opposed to an actor. So, which can have its own life, basically. Events happening separately, like in journal events, not necessarily messages coming through, right? And you can have some logic inside, basically like maybe even hierarchical state machine inside, right? So, what would you suggest, how to marry them, basically, how to add that behavior inheritance in a sense to objects so that one can inherit not only just methods, but also behavior in the sense in which state,
Okay.
or which event, or whatever method.
So I'll try and summarize.
Repeat the question.
Yeah. I'll try and
I mean,
summarize.
it was very long. What was
Yeah.
the gist of the question?
So the gist of it was, obviously we have kind of the traditional classes is just data and methods, and it's really just another data type in a sense. But you also have things like the actor framework and the QMH and things like that, where it sort of has an object paradigm, but actually it's like, so I've actually heard it called an active object. Quite an interesting way to describe it. So it's alive, but it still has methods and has data associated with it. It has a lot more behavior. And how do those two marry together? So I think the kind of active objects and the actors are kind of a step above the traditional OOP. There are design patterns that aim towards that. So obviously the actor framework uses the command pattern as the basis of that. In terms of how you have these kind of become part of an inheritance hierarchy, I think it's kind of beyond the standard OOP. It's higher than that. It would be some combination of design patterns, I think, but I couldn't tell you exactly what that combination is. Personally, I'm a little wary of the actor framework still, because I still like to see one diagram that I can see all the behavior on. So I haven't used that so heavily. I don't know if they've got some concept. I think there's some inheritance concept there, but I'm not entirely sure. So I guess I don't have an exact answer for you, but I don't know if that helps the thought process. Okay, thank you very much, everybody. I hope